Okay, so in this next section, we're now going to be adding another layer or component to our topology by adding network address translation to it. We've got full end-to-end IPv4 and IPv6 routing currently with OSPF. Now, if you would also skip the OSPF section, as long as you had the EIGRP working, you could still do this. So as long as you have end-to-end network connectivity with either EIGRP or OSPF, doesn't matter, but you have to have one of those two running in order to have the network address translation working. So let's go into this. Make whatever configuration changes are necessary to ensure that R3 is no longer advertising subnets K, L, or X. So those are his loopback interfaces via any interior gateway protocol. So let's just do that first before we do the subsections of A, B, and C. So all we have to do there is just remove those networks from the process, from the OSPF v3 and v6 process. Actually, I think all of this section is going to be on IP version 4. So I'm going to leave IPv6 alone, and we'll just remove it from the IP version 4. So router 3, here we go. Show run section OSPF. So all we're going to do is remove those network statements that cover the loopbacks. So that's going to be network 8.128, so let's get rid of that. 8.192, that's loopback 1. And the 333 network, that's loopback 2. Okay, so at this point, those networks should be gone. Let's just go across the cloud to router 2, just to verify that. Show IP route 333.1, subnet not in table. Okay, so it worked. Okay, R3, R4, and R1 should still be able to ping each other across the frame relay WAN. Okay, they still should. We didn't do anything to prevent that. R3, R4, and R1 should still see each other's OSPF neighbors. Okay, well, they currently are. You may not disable any interfaces to accomplish this objective. Okay, no problem. All we did was remove the network statements from R3. So we've accomplished 1A, B, and C. Task number 2. Configure static routes on R4 so that R4 has IP reachability to subnets K, L, and X on router 3. Okay, well, we've already done static routes, so that shouldn't be very difficult. IP route 190.190.8.128, and that's a 26 mask. It's going to be 192, and the next hop is going to be 190.199.34. Yeah, because we weren't specifically told what next hop should be used on the static route. Okay, and now let's redo this, but with the 8.192 network, and that is a /27 subnet mask. Okay, and lastly, let's redo this with the 333 network. Okay, so we've got our static route. So at this point, our 4 should have reachability to those loopbacks. Ping. Yep. That looks good. Okay, so we've accomplished task 2. Configure NAT on R4 such that it meets the following objectives. By the way, let me just pause for a moment here. Can somebody just weigh in real quick and verify that the audio and video are okay on your side, that you're able to hear and see everything okay? I didn't do that right after the break. Great. Thank you, guys. Okay, configured NAT on R4 such that it meets the following objectives. We got 4 objectives here. Any packet received from the host of 3331 and destined for anything in subnets A through G should always be translated to the source address of 44.44.44.5. So let's just draw that so we can get a clear picture of what that's talking about. So what we're saying here is that if a packet is sourced from this here, and it comes in, not really sure where it's going to come in, but let's just say it comes in this way, and it's going to any of these subnets right here, when it leaves this router, the new source address should be 44.44.44.5. That's our first task. Okay, so before we move on to 3B, how would you accomplish 3A? What commands would you do? It's actually going to be fairly intensive. There's quite a few commands there to accomplish. Let's work through this, because it's actually a lot of commands. Bring up good old trusty Notepad and start doing this. Okay, so step number 1, we want to configure, in order for NAT to work, NAT relies on the concept that when a packet comes in, the NAT process has to say, okay, either yes, that packet is a candidate for translating, or no, it's not. And there's several criteria that NAT goes through to answer that question. One of the first things it looks at is an access list. We typically use an access list to say, okay, if a packet matches this access list, then it's a candidate for NAT. That's one way. Now in this particular case though, actually let me ask you another question. There are various flavors of NAT. Like for example, here in 3A, we're being told that whenever this host of 3331 sends a packet through this NAT router, this host will always be translated to the exact same address of 44.44.44.5. What flavor or version of NAT does that? Where it's a one-for-one mapping, where this one host is always translated to this one new address. That's right, Michael. That's right. Neil and Asif, that's right. It's static NAT. So that's what we're configuring here in 3A. So let's configure static NAT. Now static NAT doesn't require any kind of an access list because it's right there in the NAT command. So we would say IPNAT inside source static, and then we would give the inside local address, which is 3331, and then the inside global address. How is he going to be seen by the rest of the world? 44.44.44.5. Okay, and then in order for NAT to work, the router has to identify which interfaces lead to my interior or inside private networks and which interfaces lead outside to my untrusted public networks. Now if we look at our topology diagram right here, we can see that in order for router 3 to get his packet to router 4, there's actually several different alternatives. He could take the PVC, the DELC that goes directly to router 4. He's got another DELC that goes to router 1, and then router 1 could route it to router 4. He could send it to router 1 across this interface, and then it could go up, or it could come in here. But basically it boils down to there's two possible ingress interfaces that could receive these packets, either serial 1/0 or 1/3. Now what we could do is just define both of those as NAT inside interfaces. But let's be a little bit more specific. Let's see if we can actually figure out when router 3 using 3331 pings anything over here, which particular interface is going to receive those pings, serial 10 or 13. Okay, so the first place to start is in router 3's routing table. Let's see, in router 3's routing table, does he have a particular path that's always preferred over the other? If all of his routes predominantly choose serial 1/0.134, then that's probably going to be sending those packets this way. So let's see. Let's check out router 3's routing table and see what his preference is to get to networks A through E. Show IP route OSPF. All right, so it looks like most of those networks he's going to use serial 000.134, which is his connection into network H. So let's see here, 9.56. Okay, that's network I. We don't have to worry about that. And this one right here, 9.16, that's the loopback on router 1, so that's network N. We don't care about that. So yeah, it looks like pretty much all the time he's going to go straight to router 4 across the frame relay connection. So now that we know that, I think we can safely say that this interface should be configured as the NAT inside interface, because all of our packets are going to be coming this way. Okay, so that's going to be serial 1/0, interface serial 1/0, IP NAT inside. And we're going to be doing all this on R4. Okay. And now what about from router 4's perspective? Now, clearly if router 3 is pinging like network E, I'm guessing that's going to go out fast Ethernet 00. But what about all these other networks? Well, let's take a look at router 4 and see if he has a preference as far as what his egress interface is to reach all those things. Show IP route OSPF. All right, it looks like, let's just start with network A and B, 8.0 and 9.0. So 8.0, he's going to go across the PPP over Ethernet connection. 9.0, the PPP over Ethernet connection. What about networks C and D, 9.40 and 9.44? 9.40, well, he's going to load balance those. 9.44, he's going to load balance those. So I would say to be safe, we should probably mark both of these interfaces as NAT outside. And on this one, it's not actually going to be the fast Ethernet because we're still doing PPP over Ethernet. So we're going to have to put it on the virtual template interface instead as the outside interface. Okay. So that will be interface fast Ethernet 00, IP NAT outside, interface virtual dash template 1, IP NAT outside. Okay, so take a look at this for a moment. Michael has a good point. Michael is asking, he says, hey, what if something happened between the frame relay connectivity between 3 and 4 and router 3 decide to reroute his packets maybe this way, and maybe it came in across the PPP connection. Yeah, so in this particular case, as a safeguard, we could make serial 1/3 as a NAT inside interface as well. Let's go ahead and do that. I don't think it's going to hurt anything. So interface serial 1/3, IP NAT inside. Okay. So just based on what I've got here, do you think this will be sufficient for router 3 to get his pings to router 4, have those pings, let's just say, for example, router 3 is pinging loopback A. Okay, so let's go back here. Let's say this is our source and this is our destination. Okay, so that's where we're going. Based on that, do you think that what I have here is enough to get this to work? To get the pings all the way to network A and get the ICMP replies back to router 3? Dwayne, you have a good idea, but what you're suggesting is a CCNP topic. CCNA does not deal with redistribution. But I'm going to mark Dwayne's comment public. Some of you guys don't know what redistribution is because at the CCNA we don't talk about that. But take a look at what Dwayne wrote. He said, need to redistribute static route. What do you think he's getting at there? What is the problem that you think Dwayne is trying to solve with that comment? The problem is these packets are going to be now sourced from 44.44.44.5. So if we go over here, not over there, come on, bring me back to my topology, right here. As these packets leave, and we don't really know if they're going to go this way or if they're going to go this way, but what we do know is when they pop out of router 4, they're going to have a new source address of 44 dot something. Do any of these devices know where 44 dot anything lives? No, they don't. So the pings will make it to the destination, but in this case, when router 2 goes to reply to those pings, he's going to say, in my routing table, I don't have any route to anything even remotely looking like 44, and he's going to drop them. So what we need to do is we need to say, okay, router 4, if stuff is going to be leaving your router with a source of 44, you are the one responsible for letting everybody over here know how to get back to you. So here's my question to you. How do we get router 4 to advertise a route, or I should say advertise an LSA, into OSPF saying, hey guys, I own the 44 network? Well, why don't we do this? Why don't we create on him another loopback with 44 dot something as his address, and then just include that in the OSPF process. So we'll create, like, I don't think he has any loopbacks right now. So we'll create loopback 0, address it with 44 dot something, and then we'll include that in our OSPF network statement. And so all these devices now will know how to reach 44 because router 4 has advertised it. So we need to do that as well. So here's what I'm going to do. We'll say interface loopback. Let's see here. Does router 4 already have any loopbacks? Show IP interface brief. No, he doesn't. Okay, good. So interface loopback 0, IP address, we'll just say 44.0.0.4, 255.0.0.0. Router OSPF1, network 44.0.0.0.255.255.255, and we're going to be advertising that as part of area 0. Doesn't really matter which area it is as long as it's included in a network statement. So that should be sufficient to get the pings translated, to get the pings to their destination, and then for the destinations to reply to those pings. Okay, so let's try it out. And see, our first thing here is our inside local address, which is 3331. And now we want the inside global address, what's going to be translated to, which was 44.44.44.5. Okay, while I'm here, let's go ahead and just paste all the rest of this stuff in. Don't have to worry about this because we're not using, well, don't have to worry about that. Okay, so let's go ahead and see if a ping works from router 3. Ping 190.190.8.1, so that is subnet A. That's loop X0 on router 2 at the far end of the topology. And it works. How can I verify that that was actually translated? How can I verify that NAT did its job and translated that packet? I can use the command show IPNAT translations. And there it is. Inside local, inside global. Okay, great. So that completes that particular objective. So that was 3A. What about 3B? Any packet received from any host in subnet L, so that's also on router 3, and destined for subnet A, should always be translated to any available source IP address in the range of 44.6 through 44.8. What kind of NAT are we describing there? That's right. Thank you, Michael. That is called dynamic NAT. So 3A was static NAT, and now we're being told to do dynamic NAT. So dynamic NAT does require that we create an access list to match on the packets that we want to translate, and that we create a NAT pool. And that pool will have addresses from 44.6 through 44.8 available. Okay, so we said subnet L will be the source. Okay, so let's go ahead and create our access list. Access-list, we'll just use a standard access list for this. Access list 1, permit, subnet L is 190.190.8.192, and it's /27, so that'll be .31. Okay, and now up here, I'll create a NAT pool, IP NAT pool, we'll just call it INE, and I don't have memorized the exact syntax of this command, so I don't want to get it wrong. IP NAT pool INE, and then we put our starting address. I'm just doing this for and the ending address and the net mask or prefix length. Okay. Okay, so this will be IP NAT pool. Our starting address is, let's see here, according to this, 44.6 and ending with 44.8. And we'll just do a /24. And now we're going to have our IP NAT inside source list 1. So we're saying any packets that match access list 1, translate them to an address available in the pool called INE. Okay, so let's put this stuff in here. Okay, that should be all we need. So let's test that out. Actually, you know what? No, that's fine, that's fine. Okay, so let's go to router 3, and now we'll say ping. Now previously this actually was not a very good example. Why? Because when I did ping 8.1, I neglected to include the source address in the ping. And so without saying the source address, router 3 was going to use whatever IP address he had on this interface as his source. But we wanted to test it by using this as the source, because this is what's being translated by the static NAT. So let me just do that real quick. Source loop 2. Ah, okay, something is not working correct. So our static NAT is not fully functional yet. Show IP route. Do I have a route for this? Yes, I do. It's known via .33. Okay. Show IP route. Okay, he's got a route. All right, and he's going to send on the virtual access interface. Show IP NAT. Well, the translation, this is, okay, well, he did do a translation. The translation was successful. It says here ICMP from 3331 going to 444444. All right, so that's the new source address. Now, when router 2 got that, let's just verify that router 2 has a route back to that. Show IP route 444444.5. Aha, here's our problem. Show IP route OSPF. Ah, okay. What's the problem here? The problem is when I create that loopback on router 4 with the intention to advertise the 44 network, I forgot to include the IP OSPF network point-to-point command. And so it's being advertised as a /32. Okay, that should solve our problems. Let's go back to router 3, do our ping. There we go. Okay, so that's functional. Okay, so now let's go ahead and test our dynamic NAT. Okay, so with dynamic NAT, we're going to have our source now be, I'll ping the exact same address, but I'll have it sourced from loopback 1. Success! Yay! Show IP NAT translation. And there it is, using 44.6. That's the dynamic translation. Okay, so that we've accomplished 3A and 3B. 3C, any packet received from any host in subnet K and destined for subnet A should always be translated to R4's fast Ethernet 00 local IP address. What kind of NAT are we referring to there? That's right. That actually goes by two different names. Either one would be correct. It's either port address translation, PAT, or sometimes it's also called NAT overload. They both mean exactly the same thing, NAT overload and PAT. Okay, so let's go ahead and do that. So that's sourced from subnet K. So we're going to have to create a new access list for this. Access-list 2 permit 190.190.8.128 000.127. Okay, and up here we will say IPNAT inside source list 2 interface fast Ethernet 00 overload. Okay, so let's go ahead and put that in there. Okay, and let's test that out. This is going to be sourced from loopback 0. Success. Show IPNAT translation. And let's see here, that came in from 8.129. Here we go. So here was our inside local, and here it was translated to 9.50, which is the same address on router 4's fast Ethernet 00. Packets originating from subnets H through J, M, N, and Y should not be translated. Yep, they will not be, because right now packets sourced from any of those subnets will not match any of these access lists. They will not match my static NAT, and so they will be let through unchanged. Use various show and debug commands to verify that NAT is working as expected on R4. Okay, well, we've done some show commands. Let's just wrap this up with a debug command or two. So first of all, I want to clear my translations. Let's just clear all of them. Okay. Logging, buffer debug. Oops. Okay, debug IPNAT. And let's see here. Let's just start with that. Debug IPNAT. Clear log. All right, so let's test out our dynamic NAT, which is where this guy sourced it from loopback 1. There we go. And that shows us source is 8.193, translating it to 44.6, shows us the destination. And here's the reply. 8.1 coming back. 8.1 is trying to send a reply packet back to 44.6, and we convert that back to 8.193. So that works. Well, we've got that debug running. Let's go ahead and do another ping, but this time sourced from loopback 0, which will invoke the port addressing translation on router 4. And there it is, same basic output. Source is 8.129, that's loopback 0 on router 3, translated to 9.50, which is fast Ethernet 00's address. So that concludes this section on network address translation. So now we've got all of our routing protocols working. In the last section, we also implemented network address translation to get a little bit of hands-on practice with that. Now we're going to move into gateway redundancy, also known as first hop routing protocols or first hop router protocols, FHRPs. And one of those is the hot standby router protocol, HSRP, which is Cisco's proprietary way of doing this. So let's see how we can implement that in our topology. Okay, so now we're going to undo all that NAT stuff that we just did on R4.